Would you like to find your own silver? Would you like to be able to recognize silver ores? Well, in order to be able to find stuff like that, you need to kind of know what it looks like. Silver is a valuable material, and silver-bearing ores are found here and there all over the earth. Even silver-bearing minerals without having the silver extracted them, just the natural minerals themselves, have a significant value and could be sold. Hey, I'm Chris Ralph, the professional prospector, and today we're here to talk about silver minerals, silver ores, geology of silver, and hints about where you can find silver and make good money looking for silver for yourself. Now, I know guys who've done that. I know guys who've used metal detectors and other things and found some really nice, valuable silver. So let me talk more about it and we'll get into it right now. A lot of folks stack and save silver metal, and that's why silver is sometimes called the poor man's gold. And it's because it's so much cheaper per ounce, and that's part of why it's so popular as an investment. Silver straddles the world of both investment and jewelry uses, as well as having really important industrial type uses as well. Because of this, the price of silver reflects both the investment kind of demand as well as the industrial demand for silver. The truth is that a lot of silver is produced as a byproduct, meaning they're mining for copper, but they're producing some byproduct silver, or they're mining for lead and zinc, but they're producing some byproduct silver, or gold and byproduct silver. And that is why not a lot of exploration principally for silver actually happens. Some does, of course, but a lot of it really is not done, not as much as you'd think, for the importance of how silver is to our economy. In this video, we're going to take a look at the most common silver minerals, and then we'll look at the geology of primary silver deposits, and finally finishing up with some suggestions for the prospector who is out looking for silver minerals in the field. Silver deposits come in both oxidized and unoxidized forms. Rich silver minerals, you got oxidized like metallic silver and halides, and unoxidized, which is pretty much always sulfides. Now you might ask, well, what are the difference between these two? Well, what it is that if the minerals, the silver minerals, are close enough to the surface that they get some oxygenated rainwater, rainwater falls through the sky, it picks up a little bit of oxygen as it goes through, and if that oxygenated water soaks down into the ground deep enough to, and water levels vary whether you're in the desert or the mountains or the a forest or whatever, if it's close enough to the surface that the minerals get exposed to the oxygen and the water, they become altered. The sulfur in these sulfide minerals actually changes over to sulfuric acid, and that helps break down even more minerals, which releases more sulfuric acid and continues to break them down. Well, the silver doesn't go anywhere. It just changes form to this oxidized form. And then below, if you get below the water table, where it's always in the water and it's not really exposed much to the oxygen, then you get the primary sulfide minerals. Now, as I noted here, the oxidized minerals come in two separate types, which we call silver and halides, which halides are a group of elements like chlorine is the most common of them, but also bromine and iodine. And so silver comes in combination with those, but it also comes as metallic silver. Let's take a look at metallic silver first. Now, silver does occur as a native metal as metallic silver, but generally speaking, it's quite rare for it to occur as a primary, to actually, when the vein is forming, to form as silver metal. Actually, almost all the silver metal that's found by prospectors and that kind of stuff is formed as a secondary process, meaning another silver mineral, a sulfide, would be changed through the oxygen process into silver metal. In some districts, the metallic silver is one of the more valuable parts of the veins that get mined. It's a significant element that they're looking for, this metallic silver. Native silver is commonly found in the form of wires, thin flakes, or sheets that fit into cracks in the rock. But sometimes it does form into veins, where literally a large part of the silver-bearing vein is metallic silver. That's not very common. It's pretty darn unusual, but it does happen. Now, we might wonder, and I said it comes in two forms. Well, why does one form over the other? Why isn't it both, or why isn't it one or the other? It has to do with the environment of which the vein exists. So if the vein is in neutral to basically non-reactive or acidic types of rocks, it will tend to form the halides like silver chloride. If it's in limestone, if the silver deposit is in limestone, there's a higher chance for it to form into metallic silver. And that can help you if you ever go out to search for a metallic silver. Remember that veins in limestone have a much higher chance of forming metallic silver. Now, why is that? Well, it's because of remember I said that the sulfur in the sulfide minerals releases sulfuric acid? Well, the limestone is just a natural acid balancer, a natural acid destroyer. And so what happens is that acid gets produced, but the limestone reacts with it and neutralizes it. So when the acid has a chance to be neutralized, you have a higher chance of forming metallic silver. When the acid that's formed from the sulfides isn't neutralized, then you have a higher chance of forming things like silver chloride. Let's take a look at some samples of metallic silver, and we'll talk more about it.
When metallic silver does form, it often takes weird, strange, and wonderful shapes, and this is in part why it's so valuable to mineral collectors. This particular piece is from Michigan in the US. Strange wires that branch and go in different directions are very common, and these specimens are so highly prized that they're worth almost their weight in gold. This particular specimen is from Creede in Colorado. In many metallic silver specimens, the weirder the formation, the more fantastic, the stranger it is, the more valuable it is. This specimen from Norway sort of looks like the gnarly old trunk of a tree. And this mine in Norway produces a lot of very fine metallic silver specimens. The state of Arizona produces a lot of metallic silver, and this very strange piece weighs almost 20 pounds and was found in Arizona. It's called the silver dog, and for good reason. You can kind of see the shape of a dog. It doesn't happen very often, but sometimes whole portions of veins will be replaced by silver. The metallic gray-looking part of this narrow little vein really is metallic silver. This is from the Creede Silver District in Colorado. One of the things that's very important to remember if you go out hunting for metallic silver with your metal detector is that this silver is likely to come out of the ground tarnished black. This is a beautiful wire crystal specimen of metallic silver, but it's got a natural black surface tarnish. And all the pretty silver that you've seen just in the last minute or two is all specimens that came out of the ground looking pretty black like this. So if you find some black piece of stuff that looks good, but it's all black with your metal detector, well, likely you've found the right stuff. That's what the silver is going to look like.
Next, let's talk about these silver halides, or the silver chloride is really by far the most common. Silver chloride, which the mineral is called cerargyrite, is by far the most common of the secondary minerals that fall into this class. It's what you find in the field 95% of the time. The others, the halides, are only a small percentage. Sometimes this silver chloride is called horn silver because it's kind of waxy looking and can look almost like horn material. That's what the old timers give it that name for. Now, it's never known as a primary type of mineral. In other words, the hot ascending waters that form a vein don't form silver chloride, but it's formed through weathering processes that I've described in the last few minutes. Because it's formed by weathering, it's formed in or around or very near outcrops. You know, the level that is oxidized varies a lot from district to district. I know districts where the oxidized level for minerals goes down 700-800 feet. And I know other districts where the oxidized level doesn't go down much more than 50 feet. So it makes a huge difference, the type of, how much rain the area gets, how deserty it is, how far down this zone of oxidation extends. Now, like I say, it has a waxy kind of appearance. It can be buff colored to yellow or greenish. Like I say, it has a waxy kind of appearance, and it's usually soft enough that it can be actually cut with a knife. It's a very rich mineral. It runs actually more than 75% silver by weight. And so if you see anything that refers to horn silver in an old report, what it means is this cerargyrite, the silver chloride mineral. Now, silver bromides and silver iodides are known to exist, but they're closely related to the chloride and form in similar environments. Let's take a look at some silver chloride and other oxidized silver minerals, like including bind hemite, which is another one we'll talk a little bit about. Let's take a look at these oxidized silver minerals that fall into that category.
Here's an interesting piece that once was some galena. Now, as the galena weathered, the lead in the galena turned from lead sulfide to lead sulfate, and that's the light-colored, light brown buff material on the right. And then the silver in the lead sulfide separated out because they could be mixed in the lead sulfide, but they couldn't be mixed when they were weathering. And that is, the silver part is the kind of honey yellow brown to gray material on the left. But it once was originally one mineral, lead sulfide, but as it weathered, the crystallization forced them to separate. Here's a specimen where the cerargyrite, the silver chloride, is mixed with limonite. Limonite forms when pyrite decomposes. You get this basically rust, and then the rust is infused with silver chloride, so there's quite a bit of silver in this material. Here is a specimen of gray to buff-colored silver chloride from the Tonopah Divide mine in the Tonopah area. The mine hit a huge pocket of this material, which was very rich just about 100 years ago. This unusual specimen has gray silver chloride in it, but also has some wires of native silver metal in it as well. And so usually you get one or the other, and not both, but sometimes you do get a little bit of native silver and silver chloride in the same specimen. Here is a specimen of silver bromide, the yellow-green here. Usually the chloride is much more common, but the bromide, like this yellow-green, does occur in some places. This yellow-green piece is called bind hemite. It's an oxidation product from a sulfide mineral called jamesonite, which is a lead antimony sulfide. And so this mineral is still a lead antimony mineral, and it still contains the silver that was originally in the jamesonite. So it does have a good amount of silver in it.
Next, we'll take a look at the primary or unoxidized forms of silver, and they're really all sulfide minerals. Now, sometimes it's just silver and sulfur forming a mineral. Sometimes it's silver and sulfur and some other metals that could be copper or antimony, other things that just lead that combine in there to make the mineral. So it becomes a group kind of a mineral. But we'll talk about the different silver minerals, and these are the ones that form in the vein. They're the ones that are formed at the primary type as the vein is forming. The silver minerals are precipitated out, and you get these silver sulfide minerals in the ore. Now, a lot of these silver sulfide minerals are dark colored. They're like virtually black, and sometimes, in fact fairly frequently, they have this kind of sooty appearance that it's almost like soot from a fire or something like that. Now they have this appearance, and it's really fairly common. And a lot of them have the same appearance enough that it's hard to distinguish when looking at them in the field. Like if you find a sample and you see this black sooty and it's in a quartz vein and it's in the right environment for forming silver, you might think that it was silver, but it's hard to tell which of the different silver minerals it is without more testing. Now, I do want to say that just because you find someplace, a dark, sooty looking mineral that you found in a vein someplace, it's not automatically silver. There's a lot of other minerals, especially manganese, that can form an appearance that looks a lot like them. So to be sure that they're silver, you almost have to be in a known silver deposit, and it's probably more likely silver than manganese. But manganese and iron can form, sooty looking dark type deposits that can easily fool a prospector. If there is any doubt, then a fire assay can quickly show that you've either got silver or you don't. The most important of all the silver minerals is a mineral that's called acanthite. Now, in older texts that were written a while back, it's called argentite, but geologists have decided that they're going to rename argentite and call it acanthite. That's the modern name for it. Let's take a look at some different primary silver minerals.
This is that mineral acanthite, or what used to be called argentite. And you can see it's got a crystal form, but it has this sooty black look to it. It's a combination of just silver and sulfur. And while you can find nice crystalline specimens of acanthite, and they are valuable, far more common is something like this. Just a lump of black, sooty mineral. This is acanthite also, but without the crystal obvious form. Here's a specimen of acanthite, black, but with silver wires. You see the wiry mesh on the surface of this? Well, mixed with the acanthite are silver wires that are still black and coated, but if you remove the coating on the wires, you'd end up with bright silver metal. In addition to acanthite, there are other silver-rich minerals. This is polybasite. It's basically a combination of silver and then several other base metals, including antimony and arsenic and others as well. This is a nice crystalline example of ruby silver, which is silver arsenic sulfide. It's called proustite. This silver mineral is parargyrite. It's the other ruby silver. It's a silver antimony sulfide, and it again looks black and sooty, but as they come out of the ground, both of these minerals look red, but they quickly tarnish or quickly react with the sunlight and start becoming black or gray from the metallic silver that's formed in their surface. This is a silver mineral known as stephanite. It's fairly common, and it's, of course, very rich in silver. And while you can find stephanite in nice crystal forms, like I just showed you, and it's far more valuable, you're much more likely to find something like this, which is a mixture of quartz, parargyrite, which is one of the ruby silvers, and stephanite, into a single mineral without real obvious crystals of each.
Less common silver sulfide minerals include pyrrhusite, but there also is some silver produced from silver tellurides like hessite, and a really small amount from a natural silver gold alloy called electrum. Electrum is actually fairly common in Nevada and some other places that have significant silver. The other class of, I mentioned the primary silver minerals that have significant silver in them, but there's another class of sulfide minerals that are mined for their silver, so that silver is very valuable in them, and that's base metal minerals that have a significant silver content. This includes like galena. Galena is a primary lead sulfide, but it's very common that a certain percentage of the lead will be replaced by silver. In other words, it's a natural crystal, and it's one atom of lead and one atom of sulfur, but in certain places in the crystal, you may get an atom of silver and an atom of sulfur together. And so the lead may be, the galena may be 95% lead, but it may be 5% or something like that silver. So much silver is actually mined, and this is a lot of the byproduct stuff, much silver is actually mined as an element in base metal minerals. The most common, like I said, is galena. And actually silver lead or silver lead zinc veins are actually a whole class and common type of mineral vein that has silver in it. There is an old prospector's axiom that coarse-grained galena, meaning big crystals of galena, it generally has a lot less silver in it, but that's really not true. I've found by research that you can have situations where the galena is very fine-grained and it doesn't have a lot of silver, or very coarse-grained, big visible crystals, and it does have a lot of silver. It just depends on the deposit, where it is, how it was formed, how much silver was in the deposit, and a lot of other factors that go into the formation of a vein. Another thing is that some copper minerals can be rich in silver. Some copper deposits can also have significant silver, and these copper deposits would be mined and the silver would be a byproduct. The most frequent copper mineral that has significant silver in it is tetrahedrite. It's a copper antimony sulfide. But like I say, the silver gets in there and replaces some of the copper or some of the antimony into the crystal structure of the mineral. Tetrahedrite is an important silver mineral in some districts. It's a primary formation at most locations. I mean, it forms with the vein in the original form as the vein was formed. A mineral called Freibergite is actually a silver-rich form of tennantite, which is another copper mineral. It's a copper arsenic sulfide. And silver also occurs as an impurity in some places in chalcopyrite, which is an iron copper sulfide. Let's take a look at some base metal minerals that commonly have a lot of silver in them.
The gray cubes here are galena. It's a lead sulfide, meaning it's a combination of lead and sulfur, and the silver in it is just a small percentage. By weight, galena is mostly lead. It has a substantial part sulfur, but usually it's only maybe 2 to 4, maybe 7 or 8 at the most percent silver. And so silver is a minor thing because what happens is it's lead sulfide and the atoms of silver replace the lead in parts of the crystal. The amount of silver in the lead does vary quite a bit from mine to mine, and sometimes even in different places within a single mine. And it does make some beautiful crystal specimens, and these crystal specimens of galena have a significant value in their own right. But when you're out in the field looking maybe at old silver mines or silver prospects, checking out, trying to find some specimens, what you're going to see is maybe more something like this, which all the galena is intergrown, and so you don't have the nice, beautiful single crystals. But this is the more common form of lead silver ore that yields so much lead and so much silver. Or maybe you'll find specimens like these, which are just kind of an intergrown mass of galena and rock. And yet this kind of material still contains quite a bit of silver and has been mined in various places all over the planet. Another common base metal mineral that contains significant silver is tetrahedrite. It's the dark colored material here. It's sometimes called gray copper. A lot of examples are more gray. This is a lot darker. But still, it's a copper antimony sulfide. And the copper is replaced in part by silver, and so a significant percentage of this stuff may be silver, depending on the mine and where you're at. I know of places where it runs 3 to 6 or 8, even sometimes as much as almost 10% silver by weight. So here's a specimen of silver tetrahedrite ore. Now the green in the front, that's malachite, which is an oxidized copper mineral. But the gray in the back, if you look at the back side of the piece, you can see toward the top, the dark gray, that's the tetrahedrite. Like I say, it's called gray copper ore. And it very commonly has very significant amounts of silver in it.
Next, let's talk about what typical silver ores look like. Now, having looked at all those very different minerals and, so many of them look so different, it's easy to understand that, there really is no typical silver ore that, everything looks like this. There's lots of different kinds of things that are silver ores and are valuable for silver, but they have wildly different appearances. So let's take a look at a variety of different silver ores and just kind of get a feel for different things. I got to tell you that sometimes really an assay is the only way to tell. But let's take a look at some different silver ores and get a feel for what they look like.
We'll start first by looking at the oxidized ores. This is an example of well-oxidized ore from the Austin district in central Nevada. It has high values in both silver and gold, but it's well oxidized. You don't see any sulfides. This is some very rich oxidized ore from the Tonopah district. It says values 800 in silver. Well, 800 at a little more than $1 an ounce when this was mined. So that leaves us with probably something like over 600 ounces of silver per ton, and in gold, more than 30 ounces per ton in gold. You see, oxidized ores can have very high values, and this probably has concentration from secondary enrichment, which we'll talk a little bit more about later. This is an example of oxidized silver and gold ore from the Rochester district in Pershing County in Nevada. And, it doesn't really look like anything. It's just some rusty stained quartz. And, people knew about these veins for a long time, but nobody ever thought them valuable. It wasn't until after the 1900s that somebody bothered to have one assayed, and they found that they were super rich. They had quite a bit of silver and some significant gold in them as well. But because they didn't look like anything, even though the veins were known for decades in the 1800s, nobody thought anything of them until well into the 1900s, when finally an assay was made. And that's one of the lessons of the oxidized ores. You have a hard time just telling by looking at them. They can look like not much, but the only way to really be sure is have a lab do an assay test and see what really is in the rock. Here's some oxidized silver and gold ore from the Silver Peak district in Nevada. And again, it doesn't really look like much. There's no visible gold or even really easily visible silver minerals. You really have to have an assay to know what's in this. And this mine was actually worked in the 1980s. Here is some oxidized copper-silver ore, and at least with copper, when it oxidizes, it leaves its standard blue or green colored staining with minerals like azurite or malachite. And this mineral, this specimen has some of that, but it still has significant silver. 19 ounces per ton is not bad silver ore, but 4% copper is, of course, really good copper ore as well. So this is a specimen where you have copper base metal minerals that oxidize and then have silver with them. Here's some unoxidized sulfide ore from the Tonopah district. You can see this mass is really mostly sulfides with minor amounts of quartz and other things. This is a chunk of primary lead silver ore from the Eureka district in Nevada. And this piece, it's maybe about a little over a foot tall, but it probably weighs more than 50 pounds because of all the lead that's in it. And of course, the silver too. Here's another example from Tonopah with the black silver-rich minerals. Most of this is galena, but there's other silver-rich minerals in there as well. This is a specimen from the Big Bonanza, the biggest pocket of all in Virginia City, Nevada, where millions of ounces were taken out. And you can see the black silver minerals in there, and there's plenty of gold in there as well. But not all unoxidized silver ores are full of sulfide minerals. Some have a little, and that's enough. The black spots you see in this ore specimen are acanthite, and the acanthite mineral is 75% by weight silver. So even though the little black dots don't make up the majority of the rock, it still is plenty enough to turn it into an excellent silver ore.
Next, let's take a look at the geology of primary silver ores. Now, by primary silver ores, I mean the ores that form from the hot solutions that make the veins, not what they appear like after weathering, but the original forms of the ore. Let's take a look at the geology of that. Now, the most productive deposits where silver is the main valuable metal that people are after, not where it's a secondary kind of thing, is the epithermal type silver deposit. The most likely places to prospect for these epithermal type silver deposits are in regions where there have been volcanic activity. Now, I'm not saying the side of a volcano, but you have volcanic rocks spread through a wide area. Most of the deposits of this class are found in the form of fissure veins, but disseminated deposits are not that unusual either. And disseminated deposit is where you have the idea of a vein, no problem, but in places where the rock can be partially permeable, or there can be a lot of different faults breaking up a large area, you can get a large area of low-grade mineralization. That's what a disseminated deposit actually is. Now, epithermal deposits are frequently found in the igneous rocks themselves, but they can also occur in the adjacent formations that may be a little older. Those deposits can be very rich and are famous for the spectacular bonanza ore deposits of the 1800s. And examples come from all over the world, but there's many in North America, including Tuscarora, Virginia City, Tonopah, Aurora in the U.S., and Pachuca and Guantaro in Mexico, and others in Mexico. The mining districts, because they're associated with volcanism, not necessarily on the side of a volcano, but they're associated with volcanism, are frequently found around the ring of fire that encircles the Pacific Ocean. Now, they're also found in Europe in areas of volcanic activity as well, and similar deposits are known in Hungary and Romania, in parts of Turkey and other nations as well.
Here's just a diagram to help explain epithermal deposits. Down below the diagram here, you would have some heat source, whether it's molten magma or whether it's an intrusion or some other source of heat. And then coming up along a fault zone is the mineralizing fluids. And eventually you reach a boiling level. And below the boiling level, you get mostly base metals, but above the boiling level, you start getting significant gold and silver. And then as it goes up to the surface, when you get almost up to the surface, and in the yellow or the gray here, you might get mercury or antimony being deposited. And at the surface, you might have a hot springs with steam coming out.
Other types of geologic systems that contain significant silver include porphyry deposits, and these are basically intrusive related deposits, and they're usually worked for their copper or their molybdenum, and silver is often a secondary but important byproduct in some of these types of deposits. There are polymetallic vein deposits. This is a type of vein that has a number of different metals. You may have lead, you may have copper, you may have zinc, you may have silver, you may even have a little bit of gold. And they're often formed in areas that are near to porphyry deposits. So they are intrusion related and not mining the intrusion themselves, which is a lot of what porphyry deposits are, but they come in the outer zones of porphyry deposit areas. And finally, we'll talk about carbonate replacement deposits. And these are deposits where the hot waters, and they're usually acidic, the hot waters that form these various veins and sorts of things encounter limestone. Now, limestone is going to be an older rock that's deposited near an intrusion. And when these hot liquids get into the limestone, the hot acidic liquids can actually eat the limestone away, and you get a bedded replacement. And a lot of times it goes with the bedding of the limestone, and the limestone is replaced by silver bearing and base metal bearing minerals that are valuable for mines for silver. And carbonate replacement deposits are also frequently found on the periphery or nearby porphyry deposits because they are intrusion related. Let's take a look at some diagrams to better explain these three different deposit types that are related frequently to porphyry systems.
In this diagram, the porphyry, the intrusion, is the pink and salmon color rock down toward the bottom. And the red lines in the top of the pink and adjoining a little bit into the green where the X's cross back and forth, that's the mineralization part of the porphyry deposit itself. Off to the side, you see parallel veins from fractures, and that's where your polymetallic veins will be deposited. And then the blue hashed mark over there is pictured as limestone, and it's in that zone of limestone that fluids will replace some of the limestone, and you get your silver lead bedded replacement deposits.
Next, we're going to take a look at secondary silver ores and enrichment. Now, we just talked about the primary, how the initial vein formation, how these methods work, but then we're going to look at how weathering affects these deposits and can really change the nature. They can take a relatively moderate or even low grade silver deposit and turn it into something super rich. So that's a topic that's well worth knowing and understanding. It happens because in vein and other types of deposits, the process of weathering literally dissolves out these primary silver minerals and moves them. Oftentimes, because of the way veins form in fault zones, that the liquids when the silver gets dissolved, it'll basically move downward in the vein zone. It won't spread out into the surrounding wall rocks because the wall rocks aren't very they're not very porous. They don't allow liquids to flow into them. It usually stays within the vein zone, and that's why the enrichment occurs in the vein zone. Frequently, what happens is you get a vein up here, and the silver mineralization moves down, and this is eroded away, and you get more stuff moving down. And so you basically get lower down in the vein the silver that was up here in areas that are now eroded away and gone. They're up in what would be the air, and it's now down in the vein zone down below. And so you get this extra concentration of silver, and it also works for gold and copper and some other minerals as well. Let's take a look at some diagrams of how the secondary enrichment process works and why it's good for you and how you can profit from knowing how this process exists, the geologic process.
So here's a diagram of a silver vein that's been oxidized on the surface. And he says the top is the surface oxidized zone and then an enriched oxidized zone. Well, the surface oxidized zone may be partially enriched, but the most enrichment is going to come toward the bottom. And it's important to think about the fact that the vein outcrops at the surface, but before erosion, before it was washed away, the vein went up further into an area which is now in the air. And the silver that's in the part of the vein that's now been eroded away is actually moved downward into the surface oxidized zone. And that's how you can get pretty high levels of silver, pretty high grades in areas that are actually the vein is pretty low grade or moderate grade. So this upper surface oxidized zone will have silver chloride or native silver metal, depending on the wall rocks that the vein is emplaced in. And then below that, you have a enriched sulfide zone where you can have secondary acanthite, piercite, or stephanite, other silver sulfide minerals. And then below that, in the pink, is the low-grade sulfide zone, and that's the original unaltered part of the vein.
Finally, now that we understand how different kinds of silver rich minerals, we understand what ores may look like, we understand the geology of the primary silver deposits and how they're affected by weathering and enrichment for secondary. Now that we understand all the basics of that, now it's time to consider suggestions for prospectors when you go out in the field and when you might be seeking to find silver deposits. To be honest, the best place to look for silver deposits is in and around known mining areas. Where you're near a mining area but not right in it is a good place to look. Where areas that silver has been found in the past, or at least in that region, is the best place to search. I mean, if the miners found silver in these places in the past, there's potential for more silver to be found in the future. Now, if you're an individual prospector, one of the things I really want you to take out of this video is the idea that metallic silver, basically metal silver that forms by the result of weathering and surface enrichment and that sort of thing, that is a great place for you to be taking your metal detector, because silver metal is quite conductive, and so it will very much show up on a metal detector. And I know guys who've gone to areas where there's mines that produce native silver. They have the right geology, the limestone and stuff, and they've gone out with their metal detector. And even when the mine is way up here on the mountain, they're down in a drainage down below, not on the claims of the mine, but quite, a good distance down, not like a mile or something like that, but hundreds of yards below the mine. And they've gone out with their metal detectors and found really nice silver specimens. And the truth is, these metallic silver specimens, the wires, the other formations, they're very valuable. They're very desirable to collectors who like to collect mineral specimens. And the guys that I know that were doing this, they were getting some really great silver specimens. They were making some big money selling that stuff. So, it's something that a lot of prospectors don't think of or don't do. But if you're in an area where you've got metallic silver in your region or easily accessible to you, that's a great idea, a great place to go looking with the metal detector. Known silver deposits have certain recognizable characteristics that help the prospector identify them. Because they form near the surface, in fault zones, open cavities and small crystals are often good indicators. And the textures such as brecciation, where the rock has been broken up, and comb type structures or banded type structures are common features of silver bearing veins and lodes. The ore is usually confined to the fault zone, but sometimes the values do go out a little ways into the country rock, so you will get a little bit going out, but the bulk of the values are going to be in the vein itself. When prospecting for the epithermal type of deposit, country rock alteration is something that prospectors can use as an indicator of nearby mineralization. The type of alteration that's most common is called propylitic alteration. It's basically where different minerals have been altered, a lot of times to clays or to oxides. And this type of alteration is often spread over a larger area. You may have a silver deposit in it, but the zone of alteration is bigger and is easy to use as an indicator. The type of alteration mostly results from the addition of sulfur to the rocks and minerals in the area. So what happens is, I told you have these hot circulating fluids that lay down veins and that kind of stuff. Well, a lot of times if the rocks are porous at all, the hot circulating fluids will spread out to a further area. It will introduce sulfur. Basically, it ends up being pyrite into cracks and breaks in the rock. And then as weathering occurs, the pyrite turns to sulfuric acid, and you get this alteration because the acid leaches the minerals that are in the rock, feldspars and stuff like that, turns them to clays. And so it affects the rock, and the alteration zone is usually much bigger than the vein zone itself. There are situations where it spreads out so much you even get mineralization going into the country rock, and that's how you can get a low-grade disseminated deposit, and those can be extremely valuable because even though they're low-grade, they're often huge, and they can have millions, hundreds of millions of ounces of silver in them. And like I say, the prospector searching for silver deposits should consider outcrops of leached rocks because they can lead you to these vein zones. The presence of leached rock is considered a very favorable indicator. The presence of caldera systems in the area. These are a type of volcano, but it's a volcano that doesn't stick up above the ground. It's basically a huge explosion, and they're often pretty much flat or may even have a slight depression to the caldera. Areas of silicification of the rocks where quartz and silica have come in and fortified the rock and made them, like a sort of almost agate-like type of material. Those can be favorable indicators as well. The search for these low-grade, disseminated, bulk-type silver deposits has not been as intense as the search for similar bulk-type deposits of gold. And so there still is potential out there. Now, in Nevada, we've had a couple of these that have been found over the years. And let me show you one of them, and we'll talk a little bit about it. It's the Rochester mine. We'll take a look. Let's look at a photo.
This is the Rochester silver mine in northern Nevada. It produces a little tiny bit of gold also. Rich veins were discovered here a little more than 100 years ago and were worked 100 years ago by the old-time miners, and they did pretty well. But drilling around the area in the 70s and 80s discovered the fact that the mineralization extended into the volcanic rocks as well. It wasn't just the veins, but the volcanic rocks, the country rocks surrounding the veins had some mineralization too. Sure, it was low grade, and the old-time miners couldn't have mined the low-grade stuff, but the modern miners can dig this stuff by the thousands of tons, put it on a heap leach, and recover silver and a little tiny bit of gold from this. And so this is what I'm talking about by a large disseminated deposit. If you could find something like this, you'd be a very wealthy person.
Now, when searching for silver deposits, knowledge is the key to your success in doing that. And that's why we've talked in detail. It's been kind of a long video talking about silver deposits and silver minerals. But there's a lot of knowledge that you need to have. And because knowledge makes the difference for the prospector, I wrote a book. It's called Fistful of Gold. And it talks about gold, but it also talks about hard rock and vein deposits, and it certainly talks some about silver as well. And it's going to be something that's very helpful to give you the experience that I've gained over 40 years of prospecting, plus my degree in mining engineering. And I'm going to tell you a little bit more about my book right now.
So this is my book, Fistful of Gold. You can see it's an encyclopedia distilling down my 45 plus years of prospecting experience plus my degree into the parts that you need to know. I spent most of 10 years writing this. It was not just a simple effort that, I sat down and wrote it. You can see it's like 250,000 words. It's not something you're going to read through in a day or maybe even a week or more. But it's got a lot of information and reference material that you can come back to. You can read it once and read it again and get more out of it because there's just that much depth of material in this. I wrote this book because I want you to have the skills to go out and find fistfuls of gold for yourself. And if you have the skills and know what you're doing and get out in the field and make a real effort, you can find significant gold. It's not easy. I'm not going to tell you that because, gold, it wouldn't be, close to $2,000 an ounce, which is what it is right now. It wouldn't be so expensive if it was easy to find. It's not easy. You just can't walk out into an old gold field and start picking up nuggets. If the gold was easy to see and find, the old timers would have picked it up and taken it themselves. So you got to have skill. You got to know what you're doing. You got to be able to master what it takes to find gold, and you've got to have the persistence and put in the effort to find the material, to find the gold or diamonds or gemstones that you're looking for. Now, this book has geology, it has facts about gold, it has stuff about diamonds and platinum, but it's mostly about gold deposits, how gold deposits form, how placer and nuggets form, all the questions you probably wanted to ask. The book is available on Amazon, and I'll put a link to it in the description below, but you can look up on Amazon, Fistful of Gold, and by Chris Ralph, and find this book. Now, the book, if you look at it, it has a very high rating. It has like a 4.7 or 4.8 out of 5, which is really high. I mean, it's hard to please everybody, but I'm close to a 5 out of 5, not far from it, right? So it's been out. I've sold more than 15,000 copies of this book, and I've had tremendous response, tremendous positive response by the people who buy it. And I think if you buy it, you'll be just as happy with it. Now, in addition to my book, I also have a website that I do, and I'll tell you a little bit more about my website and show you some images from the website right now.
Now, my website is nevadaoutbackgems.com, and I'll put a link to the prospecting page, this prospecting encyclopedia page, down in the description below, but you can find it at Nevada Outback Gems. I sell some jewelry, turquoise, other gemstones there. I don't always keep the inventory perfectly up to date, so if you're interested in anything you see, do contact me first before trying to send me money or anything, because I want you to be able to get what you order. But the website has lots of different stories, old adventures, even some stories, true stories from the old-time miners of the 1800s. So I think it's something you'll find interesting.
The other thing I want to go back to is that all my comments, I want you guys to ask questions on the comments for my videos. I answer 100% of the comments that are made on my videos. Now, sometimes if somebody just says, hey, great video, I really enjoyed it, the comment may just be, well, I'm really glad you liked it. Or, if it's a simple question. And sometimes I get people who ask me questions, I would take a book to answer that question. And I recommend that they just buy the book. But I answer all my questions. I try to help people as much as I can. I'm here to help you. So if you're interested in gaining the skills, if you're interested in knowing what you need to know to be successful, follow along with me. Subscribe to my channel, hit the bell so that they'll let you know when I come out with new videos, and I try to do that pretty much every Saturday morning. And you'll enjoy with me, you'll come along with me, we'll have an adventure together, and we will find some nice gold and see what it's really like getting out in the woods, or the deserts, or the mountains, wherever we land, wherever the gold is, wherever the diamonds are, wherever the platinum is. Come along, we'll have some fun. And I'll see you real soon on the next video.